f of x equals to this rational function, but we have a problem because downstairs we have x and there is one value of x that cannot be calculated, and that is no number can be divided by 0. So when we have 1 divided by 0, 1 divided by 0, we can see that it's a mathematical error. So x can be any value, the domain can be any real number, but the domain cannot be equal to 0. So the domain is, you can also write just not equal to 0, or you can write x is any real number except for 0. Now this particular function, it's a bit strange, so we cannot readily find the range unless additional information is given. For the other functions we can find the range without any additional information, but here we need additional information. Let me show you why not. So take a look here at the function of y equals to fx equals to 1 by x. Instead of one smooth curve, we have this separated two curves. So one domain, if you think about the range from here, from 0 to greater than 0, it is greater than 0, that is the range. From 0 to negative, 0 to less than 0 for values of x, the range is going to be less than 0. So there is a tremendous problem. How do we decide what the domain is going to be? So for this type of question, they're going to tell you find the range for this single domain. For example, the question might be find the range for x is greater than 0. So you have the picture like this, and for x is greater than 0, if this is 0, so this line is the asymptote y equal to 0. So this is the shape you have on this right hand side. So for this particular domain greater than 0, the range is going to be fx is greater than this horizontal line. On the other hand, if the question was find the range for x is less than 0, that means since there are two curves, separate curves, so this is going to be the case. So here, so this is 0 and this line, horizontal line, is y equal to 0. So here the shape is below this asymptote. So the range is going to be f of x is less than 0. A rational function is in the format of a fraction. So we have a upstairs, which is the numerator, suppose ax plus b, and we have a downstairs, the denominator, suppose this is cx plus d. When we have a function like that, we cannot have a domain x is a real number because there is going to be a problem over here. Because downstairs, look here, this value cannot be 0 because in arithmetic we cannot divide a number by 0. That's not allowed. So what we do, we write the domain to be everything, but it cannot be equal to 0, the downstairs. So the value of x over here is going to be minus c minus d by c. So the domain is going to be x is not equal to minus d by c. Let me show you a number of examples. First example, if you have a function f of x is twice x minus 1 divided by x minus 2. So we can say since downstairs will become 0 if we plug in 2, so we will say that x cannot be equal to 2, but x can be any real number except for that. Another example would be f of x is x plus 3 divided by twice x minus 6. Now downstairs, if you put here twice x minus 6 equals to 0, then x becomes 3. So x cannot be 3. If x is equals to 3, 2 3 is 6, 6 minus 6 is 0. So we can say the domain is x cannot be equal to 3, but it can be any other real number.